Okay, here we go.
Here we go. As I live and breathe. We are members of the board and hardcore supporters of the Central South Coast of California's longtime Astronomy and Telescope Club, the Santa Barbara Astronomical Unit. And this is the SBAU Astro Hour, a weekly online blog using Zoom, focusing on the latest space news and discoveries, cutting-edge cosmology, hardcore astrophysics, featuring some of the brightest, most knowledgeable people in Santa Barbara, California, at least that I know. I don't include myself in that because I'm the interviewer. I ask the questions, don't give the answers. I'm your host, Ron Heron, proud to be SBAU's vice president. We will meet the rest of the club's movers and shakers in a moment. Meanwhile, you can watch us, comment questions on the bottom of the YouTube screen during the show, Mondays, 11 to noon, or plan on joining the club. Come on out to our first Friday night of the month meeting. There's one this Friday with Bob Berman, editor or the columnist in Astronomy Magazine of Strange Universe. He'll be talking to us by Zoom from the other side of the country. Saturday night star party follows, the second Saturday. And we're even going to be out that Saturday morning at Camino Real. We'll talk about that with our outreach guy here in a minute. In the meantime, let's find out what's going on today. Before we go out to the four gas giants and find out what they're all made of and the distant layers going down from the cloud tops, we're going to cover our just recently filled fourth super moon and show you our satellite's orbit. Gives you apogee and perigee. Got an update on the asteroid Bennu samples recently returned to Earth by NASA's OSIRIS-REx. Can you imagine Paris without light pollution? Back in the 1880s, by golly, they built observatories all over the city, and they're still there. Say goodbye to Nishimura Comet and a progress report on Arizona's giant Magellan telescope. Future will be in Chile. You're not going to believe what's involved in this. That's South America. Let's meet the gang. Jerry Wilson, beloved president. Hello, Jer.
Hello, good morning.
6 years, I think 6 years you've been at the helm. Coming up on your term limits. A great supporter of her husband is Pat Forgy, and she's his wife. Chuck McPartland is back and with us.
Hello.
And you can unmute. He's our Santa Barbara Astronomical Unit Outreach Coordinator in charge of most events, including, I guess, next or 2 Saturdays in the morning, Camino Real. We're going to be out there somehow looking at a partial eclipse of the sun, right?
Right. On the 14th, we're going to set up and be open for viewing at about 8 a.m. There's going to be a partial solar eclipse for us here in Santa Barbara. It'll reach about 70% a little after 10 a.m. And
where would be a good place in America to see it total, except it's not enough
it's
moon.
not total.
There is enough moon, isn't it, to cover the whole thing?
But hey, Ron, we have
Yes.
some friends up in Eugene, Oregon, and the path goes right over them. So
All
they'll
right.
It's kind of to the east of us.
All right, you just heard Tom Whittemore. He was editor of our SBAU monthly newsletter, married to Maureen, former science instructor at Westmont. Chuck is our outreach coordinator, and his wife is Pat McPartland, an incredible, effective merchandise manager. Also joining us today is Bruce Murdoch, who is a longtime supporter and a telescope guy enthusiast. Bruce, you going to be out there at Camino Real?
Yes, I am.
Okay.
I'm debating on whether I should bring my 8-inch or my 11-inch.
Well, I think you should bring your telescope and then.
Well, yeah, right.
do that.
We're not going to go there. I hope you have your filter. Does anybody do the little pinhole thing against the wall?
Well, something that Tom mentioned he's going to do is bring a co-lander, and that's like multiple peephole cameras, and it gives you a really awesome view.
Is that right? But
Yeah,
Also, you can use a pair of binoculars as a projection item and project it onto a piece of white paper.
Yeah, you can do that. Watch out.
If you get lucky, you can also see the eclipse through the shadow of a tree that's lets a little sunlight through.
Really?
Right.
It makes
Yeah.
instantaneous pinholes.
Yeah.
But it's not going to get dark out there really at
No,
7 o'clock in the morning. What time does it start? I know you're starting at 7, but what time does the sun start getting covered over?
Starts a little after 8 sometime
Okay.
and lasts a little over 2 hours.
Bruce is married to Tim Bonney, and he's also president of the Santa Barbara Theater Organ Society. And joining us again, Tim Crawford, who's a resident lens and telescope expert. And how's Karen, your wife?
She's fine. She just got finished painting the house. I watched.
Well, that's how you met her. She said, I'll do anything for you. And you said, go paint that my house. All right. Anyway, we got some sillies because our president sends us these incredible cartoons.
Hey, can I ask one question though, Tom? How does that colander work?
Very well.
It's pretty good.
Yeah, it works really well. It's a big answer, and it acts as a multiple set of pinholes, Tim.
Is each pinhole show the sun?
Yeah.
Or
Yeah.
Oh, okay.
Gentlemen, we have a funny on the screen, and this is Newton's first law being demonstrated by Wilma Flintstone. He's about to demonstrate to Fred just exactly how an object like him, who she's sick and tired of sitting in his recliner at rest, will change when acted upon by her force. It's going to be noisy. I've seen that before. It's a long time. I think you ran it before, Jerry.
Yeah, I did run it before. I came across it again and I thought it was really good.
Sure it is. Demonstrates. Here we go with Calvin without Hobbes, empiricist, and what is it? The unimaginable wonder. That's the whole problem, he said, with science. Without Hobbes, you've got a bunch of empiricists trying to describe things of unimaginable wonder. That's kind of
many levels to this. This is a very clever cartoon. The universe is basically counterintuitive. And yes, scientists are trying to describe it empirically. Trying to get mechanisms.
What's the definition of empirical? Just fair
empirical means, go ahead, anyone.
With numbers, with analysis.
With math, basically.
Yeah.
Okay. You suppose the rest of the lay world out there got this cartoon when they first saw it?
They don't need to. We're explaining it to them.
Oh, that's true. That's why there's silly science cartoons. All right, give us another one, Jerry. Here's the babies. What did I say about it? I don't even remember. When summer ends and the cold, dark evenings return, astronomers versus everyone else. We love it. Bring it on. Everyone else, sorry. Freeze your garbanzos off. All right. I don't recall this one, or do I? This would be, hey, the lawn edge looks great. How long does that take you? Well, it feels like it takes forever, says the gardener.
This is a fractal design.
Yep.
And a fractal means fractional dimensional, like 2.5 dimensions instead of 2 dimensions or 3 dimensions. And a fractal is defined as a perimeter of infinite length surrounding a finite area.
All right, so you're gonna have to run that. My screen froze up. Part of the problem I had earlier came back, and you guys froze, but I was still alive. What did you just say about that? What are we looking at?
A fractal.
It's called a Mandelbrot set. It's a fractal, and that's where you have something that's in between dimensions. It's not 2-dimensional. It's not 3-dimensional, and it's an infinite perimeter around.
You can continue to expand and expand and expand, and you keep saying bits of the same thing. It's infinite.
Self-similar at all levels.
Yeah.
Right.
The area never increases, but the perimeter does.
So you might call them man-made crop circles. Has nothing to do with invading extraterrestrials. Okay. All right. Speaking of extraterrestrials, they do have the same problem we do with those cats we got to dump, free kittenoids.
I didn't see this one.
Well, I definitely. All right. What is this one? Oh, can you blow that up just a little bit? And we have what looks like an android talking to a computer. Yeah,
it's talking to an obscure
screen that it can't see.
Yeah.
Oh, anybody want to guide us through this?
So what's the 50th dimensional of pi? And it's 34786 times 76. Oh, there's something on my screen. I can't read the rest. And the answer comes back 27361450090. And then this guy asks the question again in binary, and he gets the answer in binary. And then a robot comes into this robot and says, what do you think, robot or human? And the robot says, definitely robot. And they reveal the other side and said, wrong, it was human. Oh my God, incredible. And the Daily Robot says, human passes Turing test. Will humans take our jobs?
Turing was a scientist.
Math.
He was a British
Mathematician.
mathematician and computer scientist.
Okay, I did run into him. Okay, and those are definitely parts of the endless line behind the
He was the one that designed the, they called them bombs. I forgot why they called them that were used to decipher the Enigma code. So the Germans didn't have an unbreakable code anymore.
On the screen, we have the evolution of some smart products, like this one makes toast. Looks the same, but this one makes toast after making you wait for a firmware update. So it's Wi-Fi enabled toaster. This toaster makes toast by watching how you like toast. It's data driven. The fourth one has toast being made for $5.99 a month as a service. Just log in. Here's another one, makes toast and lets you know that Smucker's is on sale. It's ad supported. And the final one, toast. I'm afraid I can't do that, Dave.
It's hell.
It's named Hal and it's AI supported.
But can I see your drawings? You're getting good. Let's play a chess match, Dave. Okay, we're back with Fred and Wilma, and I guess till I get my stable screen back. Incidentally, this is the 137th program we've done, gentlemen. We're approaching the 3-year mark, and we've missed very few of these. I've missed very few. I think Jerry's been off a time or two, and Chuck, I guess you survived jury duty, but you're going back, right?
Yeah, the jury actually hasn't been selected yet. So
Do you know what kind of trial? Is it civic or civil?
no,
or-
it's criminal.
Okay, we're gonna go to the big gas bellies, and we're not talking about ourselves after a holiday meal in the backyard of Jerry's house. Jupiter, Neptune. Okay, the 4 gas giants. How do we
Yeah.
know what they're made of? How in the world do they know all this?
Well, they know it from flying around it.
Well,
Feel the
news.
difference in gravitational field. You know the difference. You know the size. You can figure out the mass distribution, and you can figure out the total mass. And because you know what a lot of the chemicals are, you can put that together into a reasonable model. And so the idea is here that the big guys in our solar system, they're mostly hydrogen, but they contain small rocky cores, or solid cores, I should say, not necessarily rocky. And it's because everything happens here because of the extremely high pressure.
Mm.
So let's see
I thought
Actually,
Jupiter would
you know,
have more layers than it shows. Because
Actually,
you
what?
go down into the metallic layer.
Well, actually, some of the more recent results from Juno for Jupiter, I think this is an old diagram. They don't think there's a rocky, solid nickel iron core anymore. They
Oh.
think that all that stuff is dissolved in the metallic hydrogen and that it's a more diffuse core with all kinds of random, fluid flow inside that gives you these
Right.
strong magnetic fields.
And you're correct. This is an earlier view of it. This is from 2004. It's from
Okay.
Astronomy Magazine.
Another way of
idea-
thinking about how they know is like a CAT scan. They take, multiple X-ray images of you or whatever from various angles, and then they compute what had to be in there to get the various attenuations they got. You got the same thing here, except it's gravity.
Yeah. Now, these, as Chuck points out, these cross-sectionals show sharp interfaces, and even this implies a rocky core. The fact that it's a solid at the core or liquid and gas at the top, that's still the prevailing view, but there's no real sharp interface here. Even if there's a solid core, unlike the Earth, which has, there's a definitely delineated line between our atmosphere and our solid core. If you jump out of a building, you come to a sudden stop at the bottom of the building. There's nothing like that on these planets. You continually, the atmosphere gets thicker and more pressure, and then it slowly turns into other phases of matter, things between liquid and solid, and right on down to the other phases of the core where it actually does get solid under extreme pressures. This is a phase diagram for hydrogen at the pressures that you see approaching where interesting things happen, like inside Jupiter and Saturn. And you can go up in temperature and you go from a molecular solid and there you pass to a molecular liquid. And that would be where there's a sharp transition. These are based on models and observations from condensed matter physics of the material under pressure in laboratories. But you can also be at very low temperatures, say 200 degrees K, actually right here, 300 degrees K. That's room temperature for us here on the Earth. And if you keep the temperature the same, you start increasing the pressure and you start passing through these different phases of a molecular solid for hydrogen.
Hmm.
You can get into an atomic liquid and molecular solid. This should be a gas. You get into atomic liquid and then atomic solids. So
the understanding, Jerry, is that all elements or compounds, which are elements joined together, can be in all the phases of matter.
all four phases. There is a diagram like this for every single element and for every single molecule that you have. There's a one that for water that has a triple point in the middle of it, which means that at that point you can have water, steam, and ice all existing at the same point in temperature and pressure. You can have super cool liquids that are a liquid but will turn to a solid if you introduce anything that allows them to condense on it and start a crystal structure growing. It was the idea of the Kurt Vonnegut's famous science fiction story called Ice Nine.
Mm-hmm.
I don't think that's the name of the thing, but that's
I
anyway.
think Cat's Cradle.
Cat's Cradle, that's right.
Yeah.
That's the name of
Cat's
the book.
Cradle and Ice Nine is the
Right.
element, crazy element.
And as pressure increases down here, you get up to face-centered cubic solids. You can get to superconducting solids. It can be hydrogen all the way down to the core. Of course, it's likely to be heavier elements, but they're not probably dominant. There are heavier elements that just by gravity falls down to the center, but they would not be the major constituent, most likely.
But you won't find granite, for example, like on Earth, solid
No.
anywhere. It's a different kind of solid.
Well,
Yeah.
this is for a single molecule. You also can have similar diagrams for alloys. You know,
Yes. Yeah, for alloys, molecules, there's a phase diagram for everything. You can tour all the different phases of material. Ice is very interesting. This is not ice. This is hydrogen. But you can get to, there's a low temperature phase of ice that is stronger than steel. And I read a science fiction story about building infrastructure on Pluto out of water ice that is in this extremely useful steel phase.
There was actually a plan during World War II that never went anywhere to make aircraft carriers out of ice.
Yeah, that was the thing called pycrete. It was a mixture of water and sawdust that was frozen.
Project Habakkuk, I think it was called.
Yes, very interesting.
And somehow they wouldn't thaw out on the ocean.
They would eventually, but
Yeah.
you had pipes and things in there to try to keep them frozen.
And very slowly.
refrigeration plant.
And
Would
you
it
can
be-
take multiple torpedo and bomb hits and only chip the surface of the material. It's absolutely amazing.
Would it be fair to say, Jerry, that the inner planets that like the one we're on, the small rocky ones, they're just the opposite? The further down you go, the hotter and the more liquid until you get a liquid core, don't we? No
There is
solid.
a compression heating, but it's overcome by pressure.
Yeah, we have a solid core.
Well, we
The
do.
reason this is not gaseous here, gaseous helium at room temperature, is because we're only going down to 10 gigapascals here. 1 Pascal is the Earth's pressure here at the surface. So that would be we'd be way out here, and it would start with a a gaseous phase of hydrogen. And then as you compressed it, that's the way liquefied natural gas is delivered. It's delivered in big pressure containers. So while it's in there, it's a liquid because of the pressure.
Really?
Yeah.
And would it be fair to say, you mentioned looking at this diagram that we're not looking at compressed water ice, but Uranus and Neptune are called the ice giants. Are we looking at ice in that case, in their cases? Down there in the deep?
We are, but it's as Chuck has pointed out several times, their ice means water ice, ammonia ice, methane ice.
And
Several
even when it's
ices.
not ice, even when it's not solid.
Yeah.
Well, it looks like they're made the same except for the color on the surface.
Yeah.
That's a joke.
So the deeper you get into a gas giant, the less gas as it solidifies, and also the hotter at the
Yep.
very center, it's really hot.
Yep.
So, to me, that means all those molecules or atoms are moving around, but they can't if they're that compressed, can they?
They
That's why
want
you end
to,
up
they
with a
have the
solid
energy to do, but it takes a lot of energy to move against that pressure. If the pressure of the core of Jupiter could reach 100 million, 10 million degrees, then it could start fusion, but it's not going to get there. Jupiter's doesn't have the mass to compress it that much.
Well, that's not according to 2001 or 2010, the follow-up. Do you remember the stupid movie they followed 2001 with?
Yeah.
Jupiter lit, thanks to those black.
I thought the special effects in those were just great.
Yeah, they found that big obelisk too, right?
My God,
That's
it's full of
2001,
stars.
yeah.
No, the 10 million degrees Fahrenheit, that's where fusion starts. Now, Jupiter at one time I've heard could have been a star, but it can't. And that's because of the,
Not enough mass.
Not big enough. Yeah.
okay.
Yeah.
Well, if science has theories about life existing on some of the moons out there that are mostly water, and they could live under that ice covering in the ocean, is there a theory that any of these gas giants might have some sort of strange life down in the upper reaches where it's still
That would be mostly speculation and hypotheses. And yes.
Yes, yeah.
The current
Whale-like
that I heard-
creatures.
When they discovered the hydrothermal vents at the bottom of the ocean where the tube worms live, their whole way of working is they don't need oxygen. They use the sulfurous compounds that come out of these black geysers in the bottom of the ocean.
So in theory, there could be some life down there
Yeah.
that we'll never see, that doesn't know about us. We don't know about them. They just live in whatever that high pressure upper layer is. And what do we got here on the screen, Jer? This looks like 4 super moons in a row. Fourth one, aren't we?
Let me try and get back to that. Somehow I've moved off from that.
Well, we are going to come back here to Earth, aren't we, to do the super moon.
You can see the, hang on, I got to start over again.
You can't go backwards on your screen?
I could, but somehow I paused it.
I hope we paid our
Okay, now
Zoom
wait,
bill.
we're almost there. We're almost there.
All right.
Okay. Now,
All
there
right.
was one question I was going to say something on. Oh, yes. You were speculating about life not on the surface of a planet. There's continual speculation about whether life can exist in the atmosphere of Venus, because they keep seeing methane and biological products up there. But these things also come from volcanoes. So I think it's interesting speculation, but I don't expect them to find anything.
What things come from volcanoes? What are you talking about? Life?
Methane.
Oh, the methane. Yeah, I've seen them depicted as floating gas bags that are alive with dangling tentacles.
Yeah.
Maybe up where near the top where it's not quite so 900-degree warm.
Things that show up in Marvel movies.
Yeah. All right, looks like you're not going to get us back to the gas giants. So
Oh, you want to get back to those?
No, let's go to the moon. Oh, there you go. You can go. All right. And this is an old picture, so it's gotten changed over time. We're updated.
Yeah.
Yes and no. The only thing you have to modify for this is imagine a blurry line separating these layers. It doesn't go sharply like this. It goes gradually. If you were to fall in there, first of all, you'd get crushed very quickly or you get poisoned, but ignore that. And just go down, you'd feel the pressure increase, and pretty soon you'd realize that the air is now more like a liquid, and then it becomes more like a liquid, and then it's becoming very viscous, like a solid or a goo. But there's no sharp layers in it. Except there might be, in the very core, there might be a phase of hydrogen where it's a superconducting solid, and superconductivity might turn on at a given layer.
But there's no layer like our atmosphere that is transparent.
Yeah. In the very, very upper atmosphere of Jupiter and Saturn, for example. Yeah.
There is.
Yeah.
Is it oxygen mostly?
No.
Helium and hydrogen.
Because all I hear are words like cloud tops.
Yeah,
It means it's all
that's the
cloudy.
safest word. Oxygen is a product of plant life.
Oh, is it? That's true.
Yeah.
I heard that.
It's
Okay.
very reactive, so you don't tend to
Yeah.
find it wandering around by itself.
Well, are there any
Oxygen
different?
on Mars has gone into the soil and has become iron oxide, red rust, and that's why the planet is red.
Is that right?
Mhm.
Can we extract it when we get there?
Yes, we can. Yes,
Uh-huh.
it's all the chemicals we need are up there. They're just in other molecules, and we have to refine them.
That was the MOXIE experiment that's on the rover that's up there on Perseverance. It was actually making oxygen from the Martian minerals.
Man, there's some great theories lately that both Venus and Mars had thriving life for millions of years, a long time ago, for different reasons. They've turned out differently, haven't they? The life went away.
Maybe.
Here we go. Supermoon.
This is
Maybe what?
there was a question last week about why 4 supermoons in a row. And the reason for that is because the moon has to be at its closest point to the Earth, the perigee. So in this particular orbit here, that's this point. So if this point in the orbit occurs when the moon is full, then we see it as a supermoon. If we see this, if we're looking at this moon and it's the new moon and it's in front of the sun, then we'd see a total solar eclipse because the moon would be big enough to cover the sun. But the reason why we see 4 in a row is that the moon doesn't have multiple apogees or perigees, I mean, but the definition of perigee is loose enough that the moon is close enough to qualify as a supermoon at a number of places along its orbit. And so as the orbit precesses around the Earth, the moon becomes full. Eventually it moves away from the perigee far enough that it's no longer a supermoon.
Well, why wouldn't we get 4 apogees now in a row? It's going to go to the other end of that elliptical orbit. And when it
Well,
gets
here's
there,
a perigee here, and here's
No,
a
but-
perigee here, but it's not at full moon.
It takes 29 and a half days to get back to the perigee.
well, I thought we were looking at the last, you show 5, but the last 4
Yeah,
were closer to the Earth.
they were
Because-
close to the Earth. They were close enough to the Earth. Technically, there's only one point that's a perigee, right here.
Oh, okay.
But this one's close enough that it looks to people on the Earth, it looks big enough that this would be counted as a supermoon too. Even though it's at perigee, but it's not, in this case shown here, it's not a full moon at perigee. But when it gets to be full moon, it'll be along this line, and that's close enough that it qualifies.
Yeah, the whole supermoon thing is a media definition, and it's within a certain percentage of perigee that the full moon happens.
Right.
So the moon is precessing slowly around that ellipse as to where it's full. And if you happen to have four months where it happens within that, whatever that percentage is, the media has decided to call a supermoon, then you can get supermoons in a row. But it will gradually precess out of that because of the periodicity.
Mhm.
Well, speaking of periodicity, when will all this happen again? A year from now, many years from now, or 4 months from now? How does that work?
It'll happen again. I don't know that
Yeah.
4 in a row
Actually-
will happen that soon, but
Yeah.
See, I grew up knowing the number, and as you did, 240,000 miles, which is average. Is that in the middle? Is that the perigee number, or is that the apogee number?
That's
Or
the average.
that's
Average.
the- So,
The full moon, the technical definition is agreed on at that it's roughly 360,000 kilometers or closer to the Earth is a supermoon.
gentlemen, my screen froze up.
Uh-oh,
Yeah, your
I can
internet.
see you okay.
Well, can you hear me?
Yeah,
All right, it came on the screen. You're unstable again. That's what took you off a couple
Yeah,
of.
it's just reading me.
Okay, we're back.
Okay, so this shows the difference in
In
size between a supermoon and lunar perigee and lunar apogee. This is the biggest it gets, and this is the smallest it gets in appearance. So it's 12% smaller and about, over here, 30% brighter.
Huh. And how many thousands of miles? That's done in kilometers, I can see, but
Yeah.
what's the difference in?
roughly 50,000 kilometers. So
Okay, which is
10,000
about-
miles, a little less than that.
About 35,000 miles.
So by the convention cited in the article I read in, I think, Astronomy, if it's less than 360,000 kilometers, I mean, which this is, then it's a supermoon.
Okay. And then if it's on the horizon, it's really big.
That just looks big. You get a feeling of it being big, but it's, you can measure it on the horizon and measure it overhead, and it's not any different.
Oh, I
Right,
understand. Yeah.
Hey, Ron, I just know something pretty interesting. Besides the overall moon, clearly it's a little bit bigger on the left than on the right. Also, look over on the right there at Mare Crisium. That's the ball. That's that ball over on the upper right. Tell me if that is smaller there where Jerry's cursor is compared to the other moon.
Well,
Yeah, it is smaller.
It actually looks like it is, a little smaller.
Yeah. Everything's smaller.
Yeah. And that crater on the bottom is a favorite that outreaches. That's
but now, which one totally obliterates the sun in a total solar eclipse? Obviously,
Big one.
The big one would.
yeah, big one.
Now,
Mhm.
you can all, go ahead.
All you see is the corona, right? With the
Yeah.
big.
We'll get to that. We'll get to that. Here, this also shows lunar libration.
Mhm.
See this, what is this, Plato? No,
Tycho.
Tycho, thank you. See, it's close to the southern rim there. And
Right.
here it's much farther away, so you can see a lot more moon down here because the moon
Good point.
the moon tips and rocks as it orbits the Earth.
Huh.
Jerry, I think you meant libration, didn't you?
Libration, yeah, libation is what you eat.
Yeah, libation is something you
You've had
drink.
too much libation.
Oh, yeah, that's right. Okay.
Look at that. I didn't see this. You didn't send
So
that.
here's the quick stats on perigee, supermoon size. It's 14% bigger and 30% brighter than the micromoon. And the micromoon, or as I used to call it, mini moon, is at the apogee
Mhm.
as seen from Earth. Now, the sun does it too. The Earth's orbit is elliptical. So the sun at perihelion, which is where it's nearest, it's biggest. And when it's at aphelion, it's farthest. So you see it's slightly smaller. It doesn't have as big a change as the moon does. The moon at apogee is very small, and at perigee, it's very big. Now, if you take the small moon and you put it on the big sun, it won't cover the whole sun. So if this is the new phase, the new moon phase, and it covers it, then you get an annular eclipse. You can still see part of the sun around the rim. And that's what we're going to see in less than 2 weeks. And this is a photograph of an annular eclipse taken through a hydrogen alpha telescope in St. George, Utah in May of 2012. And you can see this is slightly fatter and slightly thinner up here because we decided to stay in the hotel room we rented because it was over 100 degrees at the campground center on the center line. So, and this was close
Jerry,
enough.
you mentioned that you shot that. That's really nice.
Yeah, thanks.
Yeah. Mhm.
Now,
And then, what's
if you
that?
looked at, if you looked at this without a telescope, it would still hurt your eyes, right?
Oh,
Yes.
Yeah, don't do that.
Well, I mean, it's just this, are we just seeing the corona? No, there's the corona. That's
Yeah.
not.
Now here's a picture taken a few months later. This is November 2012 in Queensland, Australia. And this was taken without a hydrogen alpha filter. Now the moon is occulting the sun because here the moon is much bigger than the sun is. And you can just see a few prominences peeking around the edge right there.
Huh.
So this is when you have a big moon on top of a small sun. And that's not what we're going to see in 2 weeks.
Yeah, and Jerry, you also shot that, right?
Yes, I did.
Ancient prehistoric man must have driven themselves nuts on these obliterations that came and went. They didn't have a way of really looking at it, right at it.
No, but they
Those were
noticed all the
dragons eating
cows
the
and
sun.
chickens were going home.
Whoa, there it is. That's the one that is coming
This
up
is-
in 2 Saturdays.
Yes. And here we are along the coast of California right there. The center line passes through Eugene, Oregon,
There
Yep.
you go.
goes down through New Mexico, Texas, goes down through Guatemala. This is
Yucatan?
Peninsula.
Mhm.
And then Panama, right there's the greatest eclipse, the
I see.
duration. When I was on that trip to Queensland, one of the guys from one of the science magazines that was our docent said that no matter how long they are, because some of them can be up to 4 or 5 minutes of totality, he says they're all 8 seconds long. That's
Mhm.
subjectively how long they seem. So for the total phase. Then it goes down here through, what's this, Ecuador? And then across
yeah.
Brazil.
That's Colombia.
This is Colombia?
Yeah.
Oh, yeah, okay. Because it butts right up against Panama.
Yeah.
Panama used to be part of Colombia. So,
Well, that's certainly, that's the path of the moon only, right? The path of the sun would be right around the equator right now, right?
Run. That's the shadow path of the eclipse.
yeah,
I understand that, but the sun doesn't ever go like that, does it? Just our moon
Oh,
goes
and
across.
the moon isn't either. That's just the shadow path.
no, the sun, yeah, this would, the sun would have to be like a flashlight with one beam of light in order to give a pattern like that.
But
And
this shows it
it
comes.
radiates in every direction.
Hey, Jerry, another thing that's really interesting is those green lines, those markers there are basically a half of an hour apart, right?
Yeah.
You have, see
Yeah,
how,
1630, 1730.
so you see how fast this darn thing is going, you know?
Yeah.
So it goes basically, from, I guess that looks like Utah up there. And an hour later, it's over in Yucatan.
Yeah. Yeah, you can't keep up with it with a jet
Wow.
plane.
What causes the eclipse to be different lengths of time, the total, total eclipse to be
It's
different lengths of time? Is that just the latitudes they're at?
It's
No.
the geometry. Yeah.
Right, yeah.
It's the size of the moon. The bigger
Yes.
the moon, the longer the totality.
Okay.
If the moon is exactly the same size as the size of the sun, you would just see it instantaneous. As it just finished, been covered on one end, it would be coming out the other end.
Oh, wow, okay.
Yeah,
But
I
they,
just to mention this again, Jerry. I mean, it's interesting. Last night we saw the moon and Jupiter come up about 9 o'clock. Okay,
Yeah.
and they were really about side by side. And then about 6 o'clock this morning, okay, the moon had clearly moved way, way above Jupiter. Okay, but only 9 hours later, right? The moon moves through about a half of a degree per hour. So that was about 4.5 degrees, and it sure looked like about 4.5 degrees. So Jupiter and the moon were roughly 4.5 degrees apart this morning at 6, roughly 6.
Yeah, I saw them together last night too. Yeah, very
It's
pretty.
pretty neat. I mean, it's a neat little kind of introduction to astronomy, to see this stuff happen.
Mhm.
well, I missed it on the green lines. What do they mean? What is that? Is that time?
Those are time markers, Ron. Those are time markers, and they are a half of an hour apart. Okay?
Oh.
It doesn't matter they're in UT. It's just they're a half of an hour apart.
So,
Okay.
so by the time that red track reaches just off the horn of South America in the Atlantic, it's all over.
Yeah.
Yeah. Mhm.
Okay,
Yeah, this is the Horn of South America, not Africa.
that's what I said.
Here's the subsolar point, which when
Wow.
on the autumnal equinox was up here on
Oh,
the
I see.
equator.
Right.
Hey, Ron, here's an exercise for you. Do that map with a pencil. That's just amazing. You know, a computer would just drew that thing, you know, knowing all this info.
Well, do we prefer a full eclipse rather than a partial? I guess we do. Depends.
They're
on
all
which-
They're
good.
both pretty cool.
They're all
What
good.
is subsolar?
That's the point directly below the sun.
Right.
Okay.
This is sort of what it would look like, huh, Mark, Jerry?
This is from our museum's website of their prediction of what it's going to look like from here.
This is one that's not quite 70%, but close to it.
Okay.
Okay.
It's
So
pretty
yeah,
neat.
this is going to be from about 8 o'clock to 10 o'clock.
Mhm.
You know what I think is amazing, gentlemen? Every animal on the planet that has eyes and has ever lived, with the exception of an occasional human on drugs, knows instinctually not to look right at the sun, doesn't it?
No,
Yeah.
Because it hurts.
Some animals
They
go
only,
blind.
they only do it once.
only politicians seem to not notice that.
And it's possible Galileo lost his eyesight by doing a little bit too much solar viewing. It's possible. We don't really know.
Whoa. Pointed the old telescope at the sun. That's not good.
Yeah.
Okay.
Well, David Lent used to tell us, he's the guy that made the Coronado telescopes, that the
Mhm.
little pinholes in these filters, they add up. And so if
Yeah.
you see a little pinhole in your filter when you're out there viewing the sun, you know, you don't want to do that, because with each addition of you know, the size of these pinholes, they all add up, and they'll take the life out of your eyes.
Yeah.
It'll take years out of the life of your eyes. So beware if you're out there looking at the sun and you have a little pinhole. He was saying, just don't fill it with like an indelible marker. You know, you've got to paint that out.
Mhm.
What would happen to the Webb telescope if it managed to point toward the sun? Would it be destroyed?
I think that would probably overload its system.
Yeah.
Interesting. Okay. where
Anyway,
are we?
we are just past the full moon, and it's heading toward, I think that's on Friday is the last quarter. So we can still see some dark sky objects in this part of the sky around Cassiopeia. The W is here,
Mhm.
and nice stuff up here. Bubble Nebula, M52, a little star cluster. But the major thing pointed out by Astronomy Magazine is the Andromeda Galaxy here. You also have the pinwheel galaxy here, which is the light, the picture behind me when we get back to our faces. But the Andromeda one is very nice. And this is a particularly good amateur image of it.
Of Andromeda?
You can see the dark lanes here, and you can see that the center of Andromeda galaxy is kind of, the long axis is kind of along here, but here it curves over and curves up. So it's kind of shaped like this. And our galaxy has a similar type of warped structure to it, which is
Like a
attributed
potato
to
chip.
past encounters with other galaxies. What's that?
It's a dropped potato chip.
Yeah,
I
my-
never saw that, Jerry.
it's a half Pringle.
Yeah.
Yeah, I never saw that.
Yeah. And my favorite thing about this, Jerry, is it's in black and white.
Have we ever imaged the supermassive black hole in the middle of Andromeda? I know we have a couple
No.
of other more
No.
distant.
Not that I know of.
No.
Can't find it, I guess. We got our own, and seems to me the number, what, M83, or am I right on that number?
87.
87.
87?
87 in the Virgo cluster.
Ah,
Now, this is listed as M32, with this
Mhm.
being M31. And this one is listed as M110. That was a surprise to me. I thought it only had an NGC number, but
is that
If
part of
you
the
blow
local
up the image that you're looking at it right here, it appears to me that it's in color. It's not black and white. It's very, not much color.
Yeah,
But
the
the dark
color is very
range,
suppressed and it does look like a black and white picture.
Yeah, I'm
Mhm.
not seeing any orangey stars or anything.
No,
If
well, I
you
was
look,
looking at the brown.
if you look up here, right there,
looks slightly yellow.
yeah, you can see that, there's a slight halo around this, probably a red giant in our galaxy.
Yeah,
But that's
Mhm.
the only real hint of color, and then there's a slight greenish tinge down here.
Yes, phenomenal.
Yeah. It's an excellent picture, but when you stretch the pictures in Photoshop, if you did it, then it also desaturates the colors. So you have to stretch it non-linearly, and then you have to go to and resaturate the colors.
yeah, Control U.
Okay, yeah. Okay,
Asteroids are us, the big
so
sample.
now
picture.
a quick recap. You know, the capsule landed in Utah, and the Mormons made off with it. So the whole mission here, because people ask whether the whole spacecraft came back or just sent the capsule back. The whole Osiris Rex, which is now being relabeled Osiris Apophis, I think. Go there, Apophis. So it goes to Bennu Rex and then Bennu, which is called Rex, and then I don't know how. But anyway, it changed its name when it passed by the Earth and dropped off this capsule. And now it's headed for the a near Earth flyby asteroid Apophis. So this is the whole spacecraft. This is the capsule before it got scorched on the way down. This shows the capsule. We'll see it in a minute, opened up. And okay. Anyone want to comment further on this before I move on?
Well, it's going back out to the asteroid belt to find Apophis,
Yep.
and it's going to do the same thing again.
No,
Yep.
no.
Oh, it's just
No, it doesn't have a sample from
right,
there.
because it only has one capsule.
Yeah.
Yeah.
But it's going to go, take gravity and
Right.
other measurements of Apophis and sort of fly in formation with it. Apophis is going to fly by the Earth in something like 2026 or 2029.
I think it's
And actually get
2029.
magnitude 9, I think, so that you'll be able to see it in binoculars as it goes overhead.
Yeah.
So in that spacecraft is some sort of an arm that went down and grabbed the 9 ounces of junk and brought it back up and put it in this capsule.
Yes.
No, the capsule landed on the asteroid, and then they blew nitrogen against the
Right.
asteroid and stirred it up, and then that's what came into the capsule.
The asteroid was like, those ball pits you see at, McDonald's for kids to play in.
Right.
That's kind of what the surface of the asteroid was like. And they dug a lot deeper into it than they expected when they touched down.
It was looser than
Oh.
they thought.
They
Would
ended
it
up leaving a crater 30 feet across, and the capsule is about a foot across.
So it would be fair to say that that's probably just a big, huge conglomeration of jillions of little dinky asteroids that coalesce together, right?
It's a
Through
rubble
gravity
pile.
to make a. Is there a big solid part, you think, in the middle of?
Probably not. It's probably full of
Okay.
voids, but there are some bigger boulders, of course.
Aha, okay, well, so when will we know what's happening next? A couple years away?
October 11 is the official date of release, preliminary release of what they found when they opened the capsule, which they're just in the process of doing it. Here's the symbolic part of this chart that shows the sample return canister being released to fall into the Earth's orbit, and the spacecraft itself turning around, not this dramatically, but heading to Apophis.
And that little asteroid picture that they have there for Apophis is actually a picture of Itokawa.
Another one. Huh?
Yeah.
Which one are you showing? This one here?
Yeah. The dog poop rolled in gravel.
Uh-huh.
Oh, and there's your date, Jerry, April 8th, 2029.
Yeah.
Well, assuming all that stuff costs an arm and a leg, I hope we can reuse that capsule.
Nope. It's contaminated.
Not gonna be done like Elon Musk's SpaceX stuff?
When,
No.
when a company like Hughes or Raytheon now, or whoever builds the thing, whenever they build it, they go through what's called that's our house cleaner banging on the wall. That they go through a
Cost benefit analysis.
risk reduction process of building. And what that means basically is at each stage, starting from the very basic stages, as you build up, you produce many of the first component parts. Out of that, you assemble many assemblies. And as you go up in the assemblies, you finally get about 3 of these spacecraft finished that can fly. But you have all these part trains left behind at different stages. So if the satellite is destroyed or something, you can go back a stage and you can pick it up and then rebuild a new one up. So every time you see a satellite go up like this, it's got this trail of parts and partially assembled things back in the laboratory. And that's what they put, I think it's the New Horizon, the one that went by Pluto, and that they put that together out of that risk reduction trail from other satellites. So that was how they were able to throw together a new satellite in like 15 months. When the funding became available, they said, yes, we'll do it. And they went around and scrounged all these parts and put that thing together. And their major manufacturing thing to make it so it was low risk was to put no mechanisms on it. That is, no gimbals, no pointing. So if you wanted to point the camera to take different pictures, you had to move the whole spacecraft. Whenever you have a mechanism in space, especially after it's been out there a long time, you have no confidence that it's going to work flawlessly. So you just have as few mechanisms as possible.
And I
You
can't
get
believe.
problems with the metal cold welding together, especially in
Yeah.
the bearings.
Mhm.
Strange things happen in vacuums that you don't expect. That's why NASA will not launch a mission unless every part on the mission has been in space before and has proven that it is space compatible.
Well, you recently showed 6 missions, I think, that we've done to the asteroid belt. These little rocks in the ring around the sun are really suddenly important to us for some reason, different reasons.
Yeah. You don't want them whacking into you.
Well, are the 2 rocks that orbit Mars, are they former asteroids?
The current thinking on that is that they're debris that was splashed up when the big impact made the Hellas Basin on Mars.
Okay, gotcha. Deimos and Phobos, I believe.
Yeah.
Mhm.
Fear
All
and
right.
terror.
Okay, this is them opening the are
Yep.
we still
Yep.
on Osiris? Okay.
These things, just the eyes showing, these are called bunny suits. And because they have big, clumsy, bunny-looking feet on them. And so that's a clean room. And here they're removing it, they're taking the thing apart. This shows the sample canister open at Lockheed. I think they're at a Lockheed facility. The lid is up. And somewhere in here is all the goodies that they want to measure. These are armholes that reach in. And of course, there's the famous cartoon of people in a nuclear lab where one guy's reaching through one way with the armholes, and the other guy's reaching from that clean area into the other area. So they're
Regular.
you had to
And the main reason, I guess, whatever the little live pathogens in the air might get on it, right?
in this, both contamination of the sample and contamination by the sample.
And not so much of something living, but just
Just
molecules that you wouldn't have been there.
Well, you can't get a complete full vacuum, can you? It's not possible. There's just something left. Little
Vacuum technology is a whole nother discipline.
is
You can
it?
get very good vacuums, usually not as good as deep space. But another thing is, if you breathe in asbestos fibers, they're sharp-ended little needles, and they irritate your lungs and cause lung cancer. And we have no idea if dust from the moon or dust from the asteroids have any similar properties. So we don't want to expose ourselves to it in any large way. The
And the whole
astronauts,
thing they're
when they
looking
came-
for, it because this is a carbonaceous chondrite meteorite, is or asteroid, is they're looking for organic compounds, and so they
Right.
don't want people to breathe on these things. So they've purged that atmosphere inside that capsule
Yeah.
to something like pure nitrogen.
Now that's worry about contamination of the sample. But
Yeah.
what I was stressing was contamination by the sample.
Yeah.
And let me just finish by saying that the astronauts noted when they got back in the Apollo capsules and they took their helmets off for the first time, they said the moon dust that came in with them smelled like spent gunpowder.
Ooh, maybe it is. Maybe it would fire if you put a bullet. Wow.
So anyway, this shows the layout of the internal capsule here. This is the capsule being opened here. And
Well,
Yep.
you and Chuck are veterans of the research and development out on Hollister. They had clean rooms, didn't they? Isn't that what that clean room is? It's devoid of any air. It's vacuum.
it's they're very intricately designed. They have positive pressure inside the room, so that positive clean air, so that if you open a door, the air always flows out. No air will flow in. So it's a slightly raised pressure. And they have their what is it, class 10,000 clean rooms, which means there's 10,000 particles per cubic meter or centimeter stuff in the thing, which is a very good clean room.
Well, how are they going to look at this stuff on the other side of a glass in a vacuum chamber?
It's not a vacuum chamber, Ron. It's just a sealed chamber.
Clean, very clean air in there, very clean
Yeah.
nitrogen.
Oh, it does have air. Okay.
Nitrogen.
Are they going to want to look through microscopes at
Yeah.
this stuff? And they can do that somehow.
They'll look through microscopes,
microscopes.
they'll look through electron microscopes, and they'll look through X-ray diffraction experiments to see what the chemicals are. They'll do a lot of things with it.
And a lot of that stuff is totally different from anything you'd find on Earth out in some desert or something. It's going to be different.
Don't know yet.
Wow. Wondering if we're going to be able to get to that last item. The Magellan telescope.
Oh, yeah, I don't think so. We'll have to do it for next time.
You got 2
Okay.
minutes.
This is
This-
1880s Paris when they had good seeing.
This is 2023 Paris.
Oh, this is,
See
yeah,
these
right.
domes up here? They used to be back in the 1880s. Astronomy was a popular hobby among wealthy people in Paris, and the light pollution was low, and so people built these observatory domes, and they had typically 4, 5, or 6-inch refracting telescopes up in these domes. And largely under the influence of this guy, Camille Flammarion,
Yeah.
yep, a French astronomer, and he wrote a lot of books about different aspects of astronomy, and he was very popular in Paris. And so they were doing that under his popularization of the thing. And he is responsible for this artwork. He generated this around 1880,
Oh, that's the guy.
which I know you've seen in many books.
Yeah.
He's making a metaphor for the workings of the heaven, through astronomy.
What's happening to the guy in the lower left?
He's looking out.
Is
See?
he? I can't see his head.
Well, he's looking
Heads
at
up here.
that makes all this work.
Oh, I see. Okay.
Yeah,
looking
he's
through
getting an insight into the mechanisms of the celestial spheres.
And did they grind their own lenses and make their own scopes?
At that time, they were commercially available.
1880.
Goland made them.
Clark,
and Fraunhofer made them.
Clark, yeah.
How
Clark,
big- They,
yeah,
we know how
Brashear,
big-
Brashear, he was
Yeah.
another builder.
Yep.
and
So
those
they were
were
quite popular. Now, I had seen this as a child, and one time I asked my dad if we could go to the edge of the earth and see, look through. And my dad said, the sky's not like this. We're on the outside of a ball and there's nothing above us except just more nothing. And I was so shocked. And I asked my dad not to tell my friends that because I didn't want my dad to embarrass me
Oh,
with his ignorance about how the universe obviously was. And it was years later I realized, oh, the old guy was right.
yeah. That's why you became an astronomer.
Yeah, well, one of the reasons, yeah.
Well, gentlemen, down to the wire here on a great, oh, there's the last shot of Nishimura, right?
Wow. Taken at sunrise over the Olympic Mountains, Mount Olympus.
You're kidding me. You could see that with your naked eye, just like this?
I don't know about that,
Well,
but the camera could see it.
Yeah, you can see it, but not as well as this.
Yeah.
So that's Greece, huh, Jerry? In Greece? Is that what you said?
No, this is
What?
Olympic Peninsula in Washington.
Yeah,
there.
Olympic Peninsula.
Okay.
But then it's gone and we can't see it anymore?
It might survive the sun, and then Australia will get a shot at it.
Well, this is after it passed the sun, this image. And
Oh,
it's on its way
okay.
out. And I think it is Australia that's getting the better views, but it's receding quickly.
Now,
All
we'll
right,
do this next time, but this is talking about the giant Magellan telescope located right there in Chile
Mhm.
on
But
this
there's-
mountaintop. No construction has started yet. This shows an artist rendition of the finished telescope. And we'll also discuss all these other things. And this is the giant Magellan right there.
That's all the major telescopes configurations around the world, right?
Yeah.
Look-
Planned.
And planned.
And I will have a
ELT
question on-
is not funded, and the 30-meter is underway in Hawaii.
Mhm.
And I'll have a question for you, Jerry, on the figuring of those segments.
Yeah,
How they
we'll
figure
discuss
each-
that. That's a good time to discuss that.
Sure. All right. Well, just we'll have to write it down again, and I'll have it in my notes next week from your talking points. This Friday, everybody, if you're watching, you know somebody that isn't in the club, bring them early. Come down to Fair Hall in the very lower end of the museum, because we may have a good crowd for Bob Berman's speech live from back east. He is the monthly, I guess, astronomy magazine columnist. And then we're going to be out at Camino Real the following Saturday, the 14th. And that night we'll have a star party. And gentlemen, I'll see you at the museum on Friday night. Get there early for the free 7 to 7:30 pre-show on the planetarium. That's for members only, right?
Okay.
Give my love to your wives and thank you. I learned a lot. We'll see you next week.
Okay.
The
I think
Astro
Bruce
Hour.
is,
And Ron,
Bruce
it's
is
not
having
members
trouble
only.
with gravity out there.
I love
It's not members only for the planetarium show.
I've always been told it was members only.
No, it's anybody who shows up.
Oh,
Right.
all right. Well, see, that's
Okay.
in contradiction to what I was told, but just show up early because we may have a huge crowd in that 80-seat theater there we call Farron Hall.
Well,
Gonna be a
also, I
good
think
one.
with the planetarium, are they gonna do the planetarium before?
Yeah.
Yeah.
Yeah,
And
good.
Berman's going to be talking about all the great discoveries in astronomy since '98. The last 25 years have changed
Okay.
everything. And the web is changing it all again. We'll see you guys. Thanks.